discussing asymptotes in this particular tutorial. We're really going to look at several different types. The first type is going to be horizontal, then we'll look at vertical, and then one called a slanted asymptote. We're going to really pay attention to what happens in a rational expression or an expression that has a fraction, specifically where x is in the denominator. We want to really pay attention to, as you can see here, I've got it circled, the leading coefficients and specifically the degree of the numerator and the denominator. If we look at this part, horizontal asymptotes are fairly simple to identify. It's just you have to remember that there's three different ways it can be found. Okay, so we're going to look at the first couple and we're going to kind of talk about them. You can read through this part here. If you haven't gotten this printed off, this is also available as a download under the download section in the tutorial. So make sure you print this off. It's got some good notes. So the first thing we want to do is talk about the different types of horizontal asymptotes. Okay, so we're going to look at them here. The first type you see is, look at the equation, f of x equals x minus 1 over x squared minus 1. Okay, look at the second one. You have x squared minus x over x squared minus 1. The differences that what you're going to see, and you can see the three differences here. In the first one we have the degree is larger on top. This one the degree is larger on bottom. And here the degree is equal. We're going to take the easiest one and kind of work up to our more difficult ones. All right, if you look at it this way, when you have the degree on the bottom is larger, the degree is 2 here, the degree is 1 on top. If you don't remember, the degree is always the largest exponent in your expression. If the degree on the bottom is larger, then you will always have a horizontal asymptote at y equals 0. And you can see this picture, you have a rational graph that goes down like this, and the top part comes down, and then it goes down like this. An asymptote is where the graph goes towards that value, but it never actually reaches that value. It gets infinitely close as far as you go out, but it'll never actually touch 0. Okay, so the easiest one is if the degree is larger on the bottom, boom, you know exactly what the asymptote is. It's going to be y equals 0. All right. The next setting is where you have the degrees that are the same. Okay, this one's just about as easy. Now, this one's not guaranteed to be the same thing all the time. This one, of course, is just y equals 0 all the time. If you have degrees that are the same, okay, you have this here. This is your horizontal asymptote. If you look at it, what we want to do is we want to divide the coefficients in front of my leading terms. In this case, I have 1 and 1, so that my horizontal asymptote is going to end up being y equals 1 over 1, or just y equals 1. If this had been 2 over 3, then it would be y equals 2/3. That's as simple as it gets. You just simply divide the coefficients. The more difficult one, and you don't really need to know exactly how to do this right now, but we will get to this in Chapter 2. So since we're talking about it, we're going to go ahead and look at it. This particular one has a situation where the degree is exactly 1 larger. Okay, in general, here's what works. If your degree is larger on the top, you do not have a horizontal asymptote, period. Okay, so if it's larger on the top by just 1, in this case we have 2 and 1. So if it's 1 bigger on the top, we have what's called a slanted asymptote or an oblique asymptote. All right, and this is how you do it. We're going to divide using long division. If you don't remember how to do that, you're about to get a crash course. And we're going to divide it into the top. This is what we have it set over here. So what you see, you have x plus 1 divided into x squared minus x. So the way I look at this one, I take this part, I look at x, I say, okay, what do I multiply x by to get x squared? Well, x times x is x squared. So I have to put the x on top. I multiply using the distributive property, x times x, and I get x squared. X times 1 is x. Now, notice the signs are different. The rule is change both signs and add. If you remember that, then you won't ever get your signs mixed up. Originally, it was positive x squared plus x, but I changed both signs, and I'm going to add these together. You'll notice every time that the first term will always cancel out. If it doesn't, you did it wrong. Now go down here, I'll add these together in negative 2x. And I ask again, what do I multiply x by to become 2x, right? So when you're looking at this x, so you have, well, negative 2 times x is negative 2x. So negative 2 times x is negative 2, and then negative 2 times 1 would have been negative 2, but I can already tell you that that's going to end up being my remainder because I don't have anything else to add. So I didn't even worry about that part of it, okay? Because the slanted asymptote doesn't really take into account the remainder portion. So I just stopped right there because that was going to be a remainder. My slanted asymptote is going to be x minus 2. Okay? And while we're at it, let's talk about vertical asymptotes. These are probably the easiest of all the asymptotes to find. The one thing you have to do in a vertical asymptote is simply take the denominator and set it equal to 0. In this case, we would set x plus 1 equal to 0. We solve for x, so I have x equals negative 1. So in this particular graph, I have no horizontal asymptotes because my degree is bigger on top. I have a vertical asymptote at x equals negative 1. And I have a slanted asymptote at x minus 2. If we look at the graph, this is what it looks like. Vertical asymptote here at negative 1. A slanted asymptote at x minus 2. So we have a slope of 1 over 1. You can see that here in the boxes. And we pass through negative 2 on the y-axis. And this is the case. Now, don't worry too much about these slanted asymptotes. That will come back in Chapter 2, and we'll really dig into that. But today, and for this particular chapter, you definitely need to know vertical asymptotes. Just set the denominator equal to 0. And if you have to factor, or if you have to do whatever, square root, or if you have to use quadratic formula, you'll solve that, whatever's on the bottom, and that'll be your vertical. For horizontal, remember, if it's bigger on the bottom, it's y equals 0. Done. If it's the same degrees, it's going to be the division of their coefficients. So in this case, it was 1. Y equals 1. And that is asymptotes for rational expressions.